All right, here's problem 12. So we're given a set of points just for fun, although you don't actually need it. I'm just going to draw them. So point A goes one step here and one step up, so it's kind of like floating here. Point B goes two steps to the left, or two steps backwards in the x direction, two steps in the y direction, and then three steps up. So point B is sort of floating up there. Point C goes 0 steps in the x direction, 4 steps in the y direction, 2 steps in the z direction. We'll call it right there. Point C and point D goes 3 steps in the x direction, 1 step in the y, and then 3 steps up. So there's point D. Obviously, very challenging to visualize what's going on and to draw it on a two-dimensional surface. I hope you can see that this does make a tetrahedron where point D is above the other ones. It has a triangular base and it has 3 other triangular faces. And all we have to do really is find the volume of the tetrahedron. I'm not incredibly proud of that drawing, but I hope that it helps you visualize it somewhat. Okay, so what we can do is find the area of the base and then dot product that with the vector that gives the height. And so what you can think of is the mixed product. This is something that we talked about a little bit, but that when you do A cross B and then you dot that with C, the magnitude of this gives the volume of the parallelepiped. But we don't have a parallelepiped. We have something that is much smaller than that. We have a triangular base, and so we do a half out here. And then we don't actually even have a prism. We have a pyramid, and so we do a third, and a half and a third makes that. And so if you do a sixth times the mixed product like this, you get the volume of the tetrahedron. So all we need to do then is define vectors A, B, and C, and we are good to go. So vector A is just going to be AB. Vector B is just going to be AC. And vector C, I could do AD or BD or CD, and I should get the same answer either way. I'm just going to do AD so that we just use vector A over and over and over again. So AB looks like the x coordinate goes down 2, the y coordinate goes up 2, the z coordinate goes up 2. Did I do that right? Yep. AC looks like goes down 1, goes up 4, goes up 1. AD goes up 2, goes up 1, goes up 2. Let's cross product the first two of those wonderful vectors. -3, 2, 2. -1, 4, 1, giving us I times 2 minus 8 minus j times -3 plus 2 plus k times -12 plus 2. Get out of the way, face. And that gives me -6, +1, -10. Great. We're going to now dot product that with the vector we haven't used yet, AD. -6, 1, -10. Dot product with 2, 1, 2. Gives me -12 plus 1 minus 20. And that makes -31. Yeah. Okay. And so then the volume is just 1/6 times the absolute value of -31, which is nothing special. 31/6. There you go. A really good thing to do if you have time is to go and try to find the volume using different vectors. So instead of AB, AC, and AD, maybe do AB, BC, and CD, and do the same cross product and dot product, and you should end up with the same thing. There you go.